Does this video make you happy? Do you feel the urge to just put some coins into these machines and see what happens? Maybe you have a gambling addiction. Up to 6% of people worldwide struggle with gambling addiction, but what does that actually mean? Today, you're going to see gambling fanatics betting on biological factors that cause an addiction to form. What occurs in the brain when an addiction is formed?
Dopamine is released when an activity is pleasurable and is recepted mostly in the brain. Addictive substances trigger an oversized response when they reach the brain. Instead of a simple pleasurable surge of dopamine, dopamine floods the reward pathway 10 times more than a natural reward. The brain circuits adapt and become less sensitive to dopamine. Achieving the pleasurable sensation becomes more and more important, but at the same time, a tolerance is built and more dopamine is needed to get the high that they crave.
What happens after you are exposed to gambling? Activation of these receptors triggers the release of second messengers like calcium and CAMP, which initiate signal cascades. These cascades cause regulation through mechanisms like protein phosphorylation and dephosphorylation, leading to changes in neuronal connectivity. Altered signal pathways can also influence gene expression, leading to changes in protein levels and neuronal functions. Transcription factors play a role in mediating the effects of drug exposure on gene expression and neuronal plasticity. Various protein kinases, such as extracellular signal-regulated kinase, CAMP dependent protein kinase, and others, are involved in the signaling pathways impacted by addiction. Repeated exposure leads to neuroplasticity, which the brain adapting to the effect through changes in synaptic strength, neuronal excitability, and gene expression. These neuroadaptations contribute to the transcription of controlled gambling to compulsive gambling, characterized by a loss of control over how much you gamble and a diminished response to natural reward. What happens in the brain during withdrawal from an addiction?
Addictions hijack the body's reward system, dopamine, which can send danger-sensing circuits into overdrive, making addicts feel anxious or stressed when not on or near the substance.
What does the body do to reset homeostasis? What is the effect of a new homeostasis or allostasis?
Overstimulation of the brain affects homeostasis, so the brain makes adjustments, which creates a new balance set point, allostasis. This occurs because the brain adapts to the constant presence of the addictive substance by reducing its sensitivity to it. This means the body needs more of the substance to achieve the same effect. Additionally, when the substance is removed, the brain's neuroadaptations intended to counteract the addiction are exposed. Because the brain has changed its balance point due to the addiction, the body now needs the addictive substance to maintain its homeostatic balance.
What is the role of the nervous system?
Exposure can disrupt the balance between brain circuits involved in reward, stress, and impulse control, leading to compulsive gambling seeking and reduced impulse control. Repeated exposure can alter the brain's structure and function, leading to changes in reward sensitivity, stress response, and self-control.
What is the role of the circulatory system? The circulatory system carries hormones like cortisol and vasopressin, which play a role in stress response and can be influenced by gambling.
So, in conclusion, because of gambling addiction, the body resets its homeostatic point. This results in addiction as the body now requires more dopamine to function at its balance point. Both the circulatory and nervous systems work together to regulate this addiction. So next time you're trying to hit it big at the casino, just know that there are many systems at play.
On board, come on! Board, come on! Why is it so slow? You worry about the board!